Hi guys, welcome to Learn Electronics Repair. We've seen this before. We've seen this one before. So this is our little charger. It's a good customer actually. I repair a lot of audio equipment for this guy. He owns a nightclub amongst other parts of his business. And they use these to charge the little walkie-talkie radios they have. The ones that the bouncers use, no doubt, yeah. So he asked me, oh, can you fix it? He gave me a few other things as well. This was one of them. So, yeah, I'll fix it for him. I'll charge him, but, you know, I will fix it for him. Probably less hassle than replacing the walkie-talkies because they probably have a whole set of these, yeah. So, this chip here is a switch mode controller, pulse width modulator. Look, there's the transformer. It's tiny. There's not much else on here, and the thought we had with this was that there was a short circuit diode here, or so it seemed. This diode is part of the circuit which keeps this chip running. It has a startup supply. Once it's started, it has its own little secondary on here called an auxiliary winding, and the auxiliary winding via this diode provides the power to keep this running. That's fairly typical for small and larger switch mode power supplies for that matter. And the reason I say we thought we have a short circuit diode across here is because it read short. There. So I unsoldered the diode and it still reads short. And I figured, and I'll link the previous video, that the short is in this chip, yeah. There's the high value resistor, by the way, that effectively starts this running. High voltage coming in here. This is connected basically to the primary of the transformer, which goes to the large, call it large smoothing capacitor, okay. So that's the startup supply, and then this diode comes back to the same place. This is the continuous supply for this, okay. The reason they do that, by the way, is twofold. One, that if you supply this chip through here, obviously you're going to have a voltage drop across here. It's going to get warm. The more current this wants to draw, the hotter that will get. So the way they make it is that this provides enough current to charge a capacitor. That one, no, probably this one actually, yeah, on the high voltage side. This one, and once this charges up to a certain voltage, this chip will start to run and draw current. But because this is such a high value, 3 mega ohms, this resistor can't actually provide enough current to keep this running. So this starts to discharge this capacitor, and when the voltage drops down to a certain point, this switches off again, stops drawing current, and the resistor can recharge the capacitor. This is not pulse width modulation. This happens quite slowly. So effectively, this needs to start running within a couple of seconds, maybe, or a second or so, to get the auxiliary winding on the transformer, this one, driving through this diode, power to keep this running, okay? The second reason, not only for efficiency of this thing running hot if it was supplying current all the time to this, is because if something's wrong, like you have a short circuit on the output or something, this can't generate the auxiliary power supply, so this just shuts back down. It's like a protection by default. It's not sensing anything. It's just that if this supply doesn't come up due to some fault, then this chip will stop. And that's why you often hear power supplies making a chirping noise. It's this arrangement continually charging the capacitor. This starts to run. The chirp noise you hear comes from the transformer due to a short on the output usually. The capacitor discharges, this shuts back down. Second later, this is charged, the capacitor back up again. It goes again. And to do that, by the way, this has a property called hysteresis. So it means that this capacitor has to charge up to, let's say, 15 volts before this will start. So until it reaches 15 volts, just a number off my head, it will depend from chip to chip, but let's say 15, so once it's charged to 15, this will start running. This will now start to discharge, but the hysteresis means that this chip, once it's started, it will continue to run until the voltage on here drops to a lower voltage, let's say 9. So all the way from 15 down to 9, this is still running. And that gives it time for the auxiliary supply to kick in and supply this permanently. It charges the capacitor back up to 15. If it doesn't happen, then this will stop when it gets down to 9. The resistor will charge this back up again. And at 15 volts, it will restart, okay? So that's the actual mechanism. But if you've seen my videos, you've heard this before, so I'll not labour the point anymore. Let's remove this chip. I have the diode here, and we will check the diode just in case there's a short on the diode as well. Okay, so this is our little diode, tiny little thing. The multimeter is on diode test mode. Let's measure it. That reads like a diode, yeah. I don't need to measure the other way because it reads like a diode. Simple. Diodes go short or open. Yeah. It ain't short and it ain't open, so it's okay. Right, we'll get this chip off and the short should go away across here then. Yeah. I could use hot air, but I think I might try to do this with 2 soldering irons. So let's see. These very cheap PCBs don't tend to like hot air too much, so if we can do it this way, all the better. So I'm going to add some fresh solder. Yeah, we can bridge the pins together, it's fine. I want a nice blob of solder on here anyway, actually. Okay, and we're going to do the same this side. Notice that the 7th pin is missing. That's like a spacer to stop the high voltage on this 8th pin from arcing over, basically. The only problem with this technique is getting the tweezers to lift this off. You need 3 hands, really. I'll try it first with just 1 soldering iron. Let's see if I can get enough heat into this to do this, okay? If not, we'll try it with 2, and we can always go with hot air. So let's warm that side up. This side's a bit more difficult. No, I think I'm probably going to be better if I can do this at all with 2. And it may be glued down, that's the other problem, okay? This may be glued down. Let's see if this helps. That is not easily coming off there. It's not moving. I have heat into it, but it's not even sliding. It's not doing anything. It's just moving off screen for you guys. This may not be easy. I have a PCB holder. Let's see if that helps. Okay, hopefully this will make this a bit easier. The thing will stay still now. Let's try again. Okay, so let's see if this will come off. I do believe this is glued. Doesn't want to do anything. Right, let's see how we can do this without damaging the PCB. I think if we can cut the 3 pins on one side of it, if we can get rid of these pins. Okay, those 2 are connected together, so there's actually only 2 connections on this side of the chip anyway. Let's see if we can do this, and I'm going to try by cutting the legs. This in itself may actually damage the pad, but we'll see. I think that one is cut. That one is cut. Okay, you saw the chip lift a little bit now. So I get my tweezers on here and hit all the other side assuming this one has cut, this first one. If we try and unsolder the actual pin, if the pin goes, it's cut. Oh, it's definitely cut. You can see from the angle there. Right. Tweezers, and I'll try this longer tip, this bent conical. Okay, it's coming. A bit messy, but it's coming. Go again. Okay. So I'm not sure if it was glued down. I'll clean that up with a bit of isopropyl. I'll also remove the excess solder. We can have a look. This tip's very good for using with the braid. Well, we can see two things. One, this was clearly glued down, and two, that I managed to damage the pads a little bit. So this one goes here. We've managed to lose that one altogether. Okay. And that one I'm not sure about. If I'd done this with hot air, I would have burnt this board, that's for sure. This stuff is horrible. It's very hard, very brittle. Okay, but we should be able to fix this. I can see that this track goes to here. That's where it goes. Not totally sure about that one. So this is pin 1 here. Yeah, this is the horrible glue. So pin 1 goes off up here. This is feedback, I think, because there's two close tolerance resistors there. We can find the data sheet. Pin 2, well, it can't go through here. There's only a single-sided board. This is not a via, so that doesn't actually go anywhere. There's a little bit more. That's the missing part of that one, okay? You can see where it's ended up. The missing part of that pad. We can put a little bit of wire here, I think. Pin 4, this is probably the current sense resistor. It's a low value. And then 5 and 6 are connected together. That's fine. And this one, pin 8, this is the high voltage pin. That's why there's a gap there. So that's okay, I think. We just check it. Yeah, that's fine. That's fine as far as there. We just need to put a little bit of wire here. That's fine, okay. And this will just read almost like a short. Okay. So, let's fix this. I think the best way to do it is to put the chip on first. And then from this pin, I just need to strap it to here. This is ground, okay. Let's look at the data sheet as well for this chip. Well, that's quite interesting, actually, because this shows pin 2 as being current sense, connecting to pin 4, and then via resistor to ground here. This will be a low value resistor, okay. If we look at our chip now, I can see that. So this pin does connect. It just connects the other way. It was just this glue that effectively prevented me from seeing this properly. So this does connect to here. Okay, so that's fine. So it is literally just this one. Just this one that's broken that we need to fix. And that's pin 3, which is the VCC, the supply. This is that diode I mentioned that red short, okay? And that's the high value resistor, the 3 meg resistor I mentioned. I'm going to solder on this side first. It might move while I do this, but if it does, it's not really a problem. I can always position it back in again. Let's try from here. Yeah, it moved because I touched it. Okay, don't worry about it. Bit of solder there. Tweezers. I'm left-handed at the moment, I may have to change around, but in fact I will. I'll come in from this angle. I'll add a little bit of flux as well. Never does any harm, often does a lot of good. Flux is definitely not overrated, okay. Right. I think it's going to be easier for this one. Yeah, look, it flowed much better there, yeah. Okay, back to my normal chunky tip. Okay, let's check we have a connection from pin 2 down to here. So that's here. Yes, we do. So that's the one that runs underneath the chip. And then we need to get a connection from here to this one. Okay. I'm going to put this under the optical microscope because I work a lot better with stereoscopic vision. So we'll go from this end. A little bit of single strand wire. Remember, this is VCC, so there's only a few milliamps flowing on this lead. I don't need any sort of thick wire. Okay, that's soldered down. Let's wait for that to solidify. Okay, it's not going to go anywhere. Now let's get the other end where we want it. It's actually soldered. The heat coming down here is actually soldered to the leg there, or to this pad. See if I can just get it where I want it to go. Nope. That was just by chance. It's managed to solder itself there. Okay, sort it out. That's much closer to where I want it to be. Yeah. Now I can move this end. Okay. Yeah, guys. And I've even tagged it down on there as well, okay? Nice. I'm sorry if that went out of focus, guys. This microscope is quite difficult. The focus for me through the optics is not the same as the camera. Okay, that's fixed. What we can just check to be sure is that the wire on the VCC pin isn't going too far under, so it's actually connected to the track which goes underneath, which we know is connected to there. So we have, as we already proved, the connection from here to here, but we shouldn't see a connection from there to there. It's not shorted to this one, okay? That's ground at bleep there, by the way. So that's the other end of this current sense resistor. Okay, that looks good. I'll clean that up and then let's try this. Oops, of course, before we do test it, we need to put the diode back on, okay? Yeah, for those of you shouting out the screen at that point. Let's just clean these pads up. It's a bit hard to see the markings on that actually, but I can just check again with the multimeter. We can see the markings on the silk screening, so we know from the little marking under here, yeah, you can see it there, that this is the anode, this is the cathode. So we put the red to the anode, okay, it should conduct if we have it the right way around. No, we don't. Oh, yes, we do. I just didn't have a good connection. Yeah, so that is the right way round. But a bit sticky there. Okay. Again, it's kind of back to front for me. I'm normally better using my right hand with the tweezers, but we can have a go. There's a bit of solder there. Let's just get us into place. Left-handed if I can. I'm not totally useless with my left hand, I'm just not as good as I am with the right, that's all. Soldered. I'm going to push down on this and I'm just going to melt that again. Yeah, it's sitting flat now. It's not quite level, but really that isn't an issue. I'll get a little bit of solder on here. Okay, and I'm going to hold this flat again so it doesn't come unsoldered from the other end. Yeah, I'm carrying enough solder on the end of the tip basically. Okay. And once again we can just check that. So positive here. Diode junction. Now we can try it. Don't try it in the PCB holder. This thing is metal, okay? This is metal. This was from Secure. Yeah, Secure. I made a little review with the soldering iron and with the stand. If I remember, I will link it. If I forget, somebody remind me after I've published. But it's a great little solder stand, I must admit. It makes this sort of thing at least doable. I've just noticed while I'm cleaning that there's a little bit of solder on this resistor here. Okay, just get rid of that. It's not a problem, it's not shorting the resistor, it just was annoying me a little bit. And it might always come off and end up somewhere where you really don't want it, of course. I'm really starting to hate these things with chips glued to the PCB, but I'm also beginning to learn how to deal with them as well. Yeah, so comments down below on that. I think that was probably no worse than any other option, put it that way. Yeah. Could have done better maybe, but that's how it went. I still think hot air, all the tracks would have come off. Right, let's try this. I'll put the current limiter light bulb in series, yeah, just in case. Try to get it to stay still a little bit. You can see it there just peeking around the corner of my monitor. It shouldn't probably light up at all because this thing should draw very, very low amount of power. Let's see if it actually works. So there's an LED which I think is supposed to light up. Okay, so it didn't light up at all. Let's just put this directly onto mains. Let's switch it on. Okay. Let's see if we have any voltage coming out of this. Oh, the green LED's lit up. It's actually lighting up, can you see it? Green LED lit, yeah. Look at that. What voltage do we have? 4.96 without a battery attached. So this is working. I've just switched it off. It's gone off now. Yeah, that's a success, guys. It works. So I'm just looking at the back of this. It says it's a 5 volt output. I think that's plenty close enough, personally. Okay. I'll just make sure that the big, it's big enough to zap you, that's for sure. Yeah, the big capacitor is still big enough to zap you, that's for certain. Let's make sure it's just discharged. So it is switched off now. Yeah, about 9 volts in it. Okay, we can put us back together. Okay, guys, so it's working, yeah? That's another one done. A little bit of a pain in the ass, really, that with that glued on chip. I really do dislike them, as I've said several times in this video, and I make no excuse for saying it again. They're horrible, but that's one way to deal with them. Maybe a better way. What do you guys think? I'm sure you have some thoughts on it, so let us know in the comments down there. Okay, hope you enjoyed it anyway, and I look forward to seeing you all soon again on Learning Electronics Repair. Ciao for now, guys.